Distributed in the slab. So our nodes goes where? Goes where? Our aim as a structure engineer to transfer all our loads assigned for the load to the soil safely. Safely. If the building moves, يا سلام. Imagine كده the slab is moving. يا حلاوة. صح كده؟ number one in the determination of the first effect is what? Will be stability of what? The stability of the structure system, which is a equilibrium or not equilibrium. Number two, stable or not stable. صح ولا لا؟ The load effect. عليكم السلام طبعا كان. Go ahead. So now we have a very important step. The first step is to define how the load will transfer to the soil. And ever our structure system will be transferred simply to the soil. So number one, if you go for number one here, we have very important, which is number one. We have here. We are printing now hard copy. They are printing. They are going. Load balance is the one of the key considerations in structure design. Of course, you cannot start the design until you define internal forces. What is the internal forces? أيوة. Normal force, shear force, وبعدين moment. Develop what? Yes, you have to buy يعني. Bring a chair, bring a chair. Allah, that's. Okay, now we have shear, moment and normal. Develop what? لا, developing stresses. This is what internal force. It will develop what stresses. These stresses we needed to design. Correct or not? Correct or not? We need to design for sure 100%. Once we define the stress on a structure or element for section, so we can design this section. Correct? And your load balance is one of the key considerations in the structure design. And it's about how to bring the load acting on the base. To the ground or foundation? 100%. We said from a while ago that our load should be safely go to ground. صح؟ through what? Slab first. From the slab to the صح؟ طب يبقى now see that number one is very simple. How many seconds you need? How many seconds you need? You need almost around 20 seconds. صح? Correct or not? 20 seconds. What is the answer then? B. Correct? صح? See, guys, it's very simple. To ground and the foundation. This is to ground and the foundation. This is the correct answer. Right. If you go for number two, you found what? Again, it's the same. It's at the same area. Which of the following reinforcement concrete beam slab floor would be considered an effective two-way system? What I see? Huh? Sorry? Two ways. What see? You have structure system. You have column in the column. Okay, this is I told you now, assume now this is the slab system, slab 1, slab 2, slab 3. Okay, we have 2 meter, 4 meter, and you have 2 meter, and 4 meter. Here, how the load in the slab will transfer to the beams? How the load? Our load. We are in this slab. We are existing in this slab. How our loads it will transfer to the beam? How? Through what? Through a direction. Through direction. صح ولا لا؟ correct ولا لا؟ بعدين معاك what to do? Your class is already. Okay, so now you have what? You have, if you have this 2 meter and the total length here is 6 meter, 400% the load it will go in the short direction. Short direction. What is the short direction? Short direction means the load it will go in this direction. In this case, why in this case go in short direction? Because listen, L over LB, L is 6 meters, over LB is more than 2. This is the criteria. If L over LB, L is 6 meters divided 2 is equal 3. More than 2, yes. You allow the loads here will go in this direction. You allow when I need to design beam 1. Beam 1. So beam 1 it looks like that. This is the column now. And this is the load coming from what slab? This part. And this is 6 meters. And here is what? Column. C1. You guys C1 support. Right. In this case, the load how will transfer? Short direction again. Type 4 divided 2 is 2. 2. More than 2. Over LB less or equal to then is what? 2 is less. 2 less. If L over B equal or less? Equal to. But this case is what? You allow 2 directions. صح كده؟ طيب here 4 divided 4 less ولا 1 less يبقى if L over B less or equal to 2 is less يبقى 2 ways 1 way you allow 2 يبقى allow to design بقى B3 you have to do what? B3 have what? Continuous speed. يبقى now this is column C2, C3, C4. You allow the column C3 here, and you have loads coming. Correct or not? Correct. You will call this continuous beam. So then C4, C3, C2. See? It's very important to define the load path. So then you will take all the direction and all the way path. Then you will start the correct. You want to know which one here, which one two-way slab. Don't forget this this criteria and this equation coming in our exam. Coming in our exam, very simple. Our exam, very simple exam. You want to know which of the following reinforcement concrete B. Done? Which of the following reinforcement concrete B slab floor? Number 8. How many slabs in number 8? Four slabs. Sure, 100% from the first impression side. You will see this slabs is 1 B. How many slabs in B? Two. You don't have some. How many slabs in B? 2 slabs. As what the same. We still have one. We have 1, 2 guys here. Again, 1, 2. Number B have 2 slabs. Number C is 1 slab. 1 slab. And the obvious case is that this is a square. It's the same condition of this slab. You will now this two-way slab. D as well as 1-way slab. You will have it. C without dimension, without anything. Like it's what engineering sense. Now we are using our engineering sense. We don't need to calculate. We don't need to do anything. Just only can. صح كده؟ طيب number 3. Number 4, 2, 3. Number 3. Number 3. Okay. Number 3. Consider the framing and the structure, the detailed design, shown the load path of this design. By the way, all of this number of questions from previous exam, يعني 1 to 12, copy paste. Copy paste by number, by everything. Could be 1 of them, or 2 of them, 3 of them, or 5 of them. Come to your exam. But anyway, we have to study. Right. Let us go for this structure system. We have cross section. This is a cross section. Okay. This cross section, we have start, we have strap, we have beam, we have column, we have footing.
Sir, can I ask you something?
Tell me.
Sir, I'm joining class just now. Can you please tell me which question you're solving now so that I can follow? Because I really don't know which exactly.
Number three. Number 3. You have
number 3 question.
Yes, number 3 now.
And it is 34 number question which you yesterday. Yeah. Number 3. 1 minute, sir.
Okay. Type.
Okay.
Let's go for this system. For sure, they are coming from strap to beam, column to footing. Which answer?
Answer D.
Answer D. Very simple. It's very simple. Yeah.
Sir, this question number 3 is different than what you are solving.
We are discussing number 3. We are solving number 3 now. Okay, solve it. Let us go for number 4.
It is.
I cannot hear
Sir,
you.
it is from yesterday. Sir,
Tell me.
It is from these 34 questions, right? Which you yesterday gave us in last class.
No, we are discussing about the 34 number problems and equations in. I said hard copy to the range and hard copy. Did you have this in our WhatsApp group? Anyway, so now.
Sir, can you hear me now?
I hear you. I hear you.
Sir, this question number 3, which you are saying, this is from 34 questions which you gave us yesterday, right?
Yes.
From that question, in that question, I'm not able to find this on third number. On third number, yeah, there.
1 minute. I will. 1 minute.
Online
our support also step. Very good.
Thank you.
We have now 1 minute. You have it now. I will send the chair in our WhatsApp group now. Bismillah.
Yeah, thank you, sir. Received.
Receive?
Yeah.
Go for number 3.
Okay.
عارف عمود مربع using supporting system what is the structure? Yes, slab. The slab will be and the assumption is known, we are fixing into support. Like you have which here typical now. Like number 4. See number 4, and we'll discuss about number 4 very important. Now, number 4, very important problem. Number 4. Number 4 have what? We have system, scaffolding system, and 2 we have this foundation A and foundation B, and you have light load, dead load, and you have wind. Okay? صح كده؟ Yes. Okay. Referring to the figure, what is the load combination produces the maximum uplift on footing A? How is the uplift? For footing A, it will be development. How? What does it mean uplift? Uplift means due to flow system, this foundation it will up like that. This is uplift. This is uplift like that. If this load produces uplift for footing A, means what the system is not stable. Correct? Right. How can you make it stable? How? Think كده. Now is this assume it's already moved. Already uplifted. How we are going to do it? The first is to see the effect of this load into a foundation. What is the effect now? What is the effect? Study we already determination of load effect. What is the load effect on this foundation? Where is the load? Of this load in the same line of action. We put it the same line of action means is the same line, acting in the same direction. Correct? Can you have one back for me? Because I have correct or not? Right. What is the load effect? Let us see what is the load effect. What is the load effect? Uplift means what? Means moment. Uplift means moment. There is this load, it will produce moment. To resist this moment, to do what? What you have to do? Increase the foundation. Increase the foundation. As much as you are increasing foundation and depth of the foundation, that is load itself, the load, it will be reversed to the line of action there. The load here. The load. So it will be resisted. Okay. And for sure, 100% this load, it will give you reaction here. Reaction here. This reaction could be. So then, as much as you are increasing the load, the foundation dimension, you can do what? You will do what? You will more stability. Or make porous foundation one foundation. Our crane fix on what? Fix a huge foundation. That very big foundation. If you have 60 meter, 50 meter tower crane with boom 60 meter, yes, a foundation back. Foundation, correct? Fine. If there is uplift to this foundation, what will happen here? What will happen for footing B? What will happen? Thinking what will happen if there is uplift here? What will happen for B? Especially in this point. Especially in this point. It's rotation, but what you call it in engineering, the science or terminology. Okay? That's a moment. That's overturning. Yeah, this foundation will be overturning. Means that all the system it will be overturning around this field. This foundation will be overturning. If you all the system, it will take all. That's meaning what this foundation it will be the nearest point to the this load is what this point to avoid overturning. What you have to do here in this system to avoid what you have to do. Very simple system. Very simple. What you have to do. The number one, correct or not? What else? Some joint condition. Make the system here. Instead, you are having cantilever. No, make the line of action of this load is the same line of action from the center of the foundation. Then there is no load. There is no what. There is no moment. There is no moment in this direction. Why? Because there is moment here. What is the moment now? This X, that you have L plus DL multiply X. This is what moment. Correct or not? Make X 0. But there is no moment. No. You have more stability for both uplifting and overturning. So what is the combination back for uplifting? What is the combination? Yeah, I know what is the combination. In the load direction, when you load in this direction, it will give you what? Give you moment here. See? That's correct. Uplift up. Correct? This is L, WL multiply what? Multiply distance. There Y. Correct? This Y. And we have LL plus BL multiply distance. What is distance here? X2. You add another A moment. See? Another moment. L plus CL multiply X2. You add a combination is what? Answer? Number T. If the wind load in this direction, what is the combination? More stability. More stability will give us more stability. As in, the combination is dead load plus live load minus simple, very simple. Correct? Type number 5. Let us go for number 5. If you engineer solve the number 5 correct, we will go for 5 star of building. Today, we will finish this platform. And we'll go for the number. Yeah. Correct? Direction different. Opposite. Number 5. Number 5, 6. Equilibrium. We talk about number 5. 5. I discussed with a while ago about tower crane. It's the same. Tower crane. This is a tower crane with 7,000 pounds. And we discussed about that's pound. You need to know that this is British units. Try to solve number 5, these guys can try to solve it. It's very simple, but we need to just try. And the practice makes perfect is very important, because who knows, could be the exam pattern change and could be another problems coming to us. Who knows? Nobody knows, but at least you will get all the confidence you need. £7, this is a British unit, different than Newton, different than kilogram units. You have tower crane, tower crane, this is a room. Here we have loads. We need to know what's the loads here. And we have counter load. This is 7,000 pounds divided 1,000. You have 7 kips. Kilo pound, you have kip. 1 kilo pound is equal 1,000 pounds. Okay, we have load of the foundation plus load of the tower itself. The tower itself is 3 kips, يعني 3,000 pounds, and the foundation is 20,000, 20 kips, يعني 20,000 pounds. And we have a ball of weight coming in CG, center gravity of the ball equal 1,000. 1,000 divided 1,000, 1 kip. Okay, now I need to estimate and determine the loads coming what it will not what it will what is the maximum. The maximum load that the crane can lift without means what? Equilibrium. We're still in equilibrium. If happen overturning, you allow is load. That's meaning what? In this case, we will assume that we will carry on, make the system under equilibrium. Make the system under equilibrium. How can we do it? I told you before in our exam is 1 to 2 equation. One or 2 equation means you can solve it in 1 equation or 2 equations. In this problem, let us see how can we solve. We have foundation. The foundation is fixed food. Fixed food. This is fixed food. And we have from the counterweight to the center of the tower is 7 food. And we have here is 5 plus 10. Plus 10. Okay. So now, where is the overturning point? Again, where is the overturning point? This is the key. To solve the problem is the key. Where is the overturning point? At this point, مثلا you can say C وبعدين you have B وبعدين you have A. And see what will happen. And see what will happen due to slope exceed the dynamic uplift here. This one uplift here. So same what we already discussed number 4. But overturning where? Overturning here. This overturning. All the system it will be collapsed here. صح كده؟ This is the uplift overturning. يبقى then where is the line of action at this point? Here we go. If you take this line, يبقى now you need to do what? This part make balance. This from here until the end here should be made balanced. You are providing a weight and counterweight to do what? Increasing counterweight or decreasing is dependent about the load you are uplifting. The load you are lifting. So now, if you need to have the equation in what the sigma moment coming produced from this load, around this point should be what? 0. If more than 0, refer to counterweight is 7,000 pounds. Then what? For sure, 100% it will be collapsed. Sure, 100%. Okay. But what is the equation then? What is the equation then? The equation should be this force produced this moment here or not? This moment is what? Distance multiply what? This x. X is equal what now? 5 minus 3 because it's 3 foot. صح ولا لا؟ correct? يبقى 5 minus 3 foot. يبقى now this is equal to. يبقى now moment force multiply distance. يبقى ادي اول force اللي هي 1 multiply 2 moment of. correct? صح؟ Okay. Put your finger here. 1 multiply 2. 1 multiply 2. Moment now. In this direction. At the moment now. At the 1. 1 multiply 2. B كمان. B multiply what? Multiply distance. 10 plus 2. 12. Now we have B multiply 12. If now there is 2 forces, it will develop 2 moments and this point around this point. But to make it balance, make another way more. But this already defined. Yeah, 7. 7 at the moment. 7 multiply what? Multiply 7 plus 3, you have 10. Huh? But what about the tower and foundation? Both of them the same line of action. Both of them the same line of action. Both of them are correct. You will take the summation. The summation is what? 23. يعني 20 plus 3. Give me a moment as well. A moment is equal what? At 1. What is 2? 1 lower 7 multiply 10. We here 23 multiply 3. Where is LB multiply 20? خلاص. Very simple now. يبقى 23 multiply 3. يبقى equation is what? يبقى B 7 multiply 10 plus 23 multiply 3 equal what? Equal 1 multiply 2 plus LB multiply 12. خلاص ماشي. نعم. Of course. Of course. Can I have blue and red, please? Okay. So now the equation now you found what? LB equal 11.41 kips. يعني 11,410 pounds. صح؟ estimated كده you'll found 11,410 pounds. يعني 11.41 kips. صح؟ طيب assume you have very nice cat or dog, 10 pounds. Climbing here, see? Climbing here and jump to this load. What will happen? In this case,
Move to the left.
now is what is equal. This is the maximum load. It will be stable. After that, if you increase 1 pound, what will happen? Some correct or not? Correct. صح كده ولا لا؟ طيب يبقى then what is the answer? What is the answer? Let us see what is the answer. 7.5. 7.5 is correct. 7.5 is not correct. Not correct because it's 11.
Okay.
Okay, what? Okay. 10.75, صح? Correct? No. This correct? No. Did I give you a factor of safety? Did I give you a factor of safety? If I told you now, there is factor of safety in 1. Assume or 9. You will do what? This answer multiply the factors. صح? But I don't give you factor of safety. Means what? Go for the nearest number 2 at 11.4. Your answer is what? 11. You will never forget this problem. Coming in your face, كده screen, yeah? I wish all of you in your exam كده just our screen. الله أكبر. Don't solve it. It will come with you now. After 2 classes from now, I'm going to ask you, what is the power crane problem? Answer. You tell me instantly. Okay? Simple, huh? See? One equation or not? One equation. Very simple. I told you that. Our exam is 1 to 2 equation, but very simple. When we start structure analysis, because it's very important. Why? To gain confidence, trust yourself, and be familiar about exam mode. And when you are going to solve problem number at home, you will solve number 13. We discussed about equilibrium enough. Already now, equilibrium enough. Yeah, number 13 is equilibrium. Number 14 is equilibrium. Number 15 is equilibrium. Number 16. And number 16 is look like number 6. We'll solve number 6 as well. Number 17 is equilibrium. Number 18 is equilibrium. From 13 until 18 is not coming from our exam. It will not. But what is the purpose for objective? The objective is you by your own training. Train yourself and study them. So what the output? The output is very nice. You will see yourself very confident. And you will be go to exam. As you in different problem in equilibrium, you are also with the uniform directly. Okay? So now about as a homework, before I give homework and the collected real from each engineer not solve the homework. I will not do it. Okay? Please guys, try to solve this one at 4, at 3 times, whatever. Let us go for number 6. Number 6 is very advanced. The same, this is the last one we discuss about equilibrium, and I will not simplify. Because I will just get ahead now, and I will send the answers now. For what? For the 34 problems. I will share the answers now. Now. So what you have to do now is just at home or at home or at free time, get exercise by your own and check your answer in WhatsApp group. Download all the answers, put it in a soft copy or hard copy or whatever, and study by your own. You will be perfect. You will see yourself. Let us go for number 6. Number 6 is the last one I am going to discuss about equilibrium. A precast wall, panel, 20 foot long, perpendicular to the drawing plan. Multiply 14 foot high and 4 inches thick. By the way, I told you 80 to 90% from our exam problems is foot pound second. This units, foot pound second, inch. Inch equal to what? 2.54 centimeter. 2.54 centimeter. From this equation, you can give me in mind how many kilometers? By 280. Yeah, if you have inch is equal to 2.54 centimeter, I can tell you now, 1 mile equal how many kilometers? Only? Yeah, exactly. Exactly. How? Start with 1 inch equal to 0.54 centimeters. Hello. I need 1 mile. It's 1 inch to 1 mile. Very important. If you go for 1 inch to 1 mile, why I'm telling you? Because this is very important.
Open.
Hi,
It's
guys.
another dump truck. थोड़ा यार जान दो इसको. नहीं.
Why, please, mute your system. Please.
Sorry.
All of you have this. Okay, now? Yes.